Hello, this is Ed Chapman, and this video cast is going to cover dehydration synthesis, which is the chemical reaction that happens in biology to join all monomers into polymers. All right. Now, the bond between monomers is formed by removing or taking away a water molecule, and that's where the name comes from, dehydration synthesis. So when you dehydrate something, you're removing water. Of course, hydration refers to water. And synthesis means to build. Okay, so when you synthesize something, you build it, and when you dehydrate it, you remove water. Okay, so the name tells you what happens in this chemical reaction. And to show you guys this, we're going to build a molecule of maltose by bonding together two glucose monomers. Glucose is a simple sugar. It's one of the smallest, simplest sugars in biology. And we're going to build a maltose by hooking together two glucoses. Okay, so dehydration synthesis produces a water molecule every time a monomer is bonded to another monomer. So let's watch this happen. So before we get to the sugar, let me show you guys just in simple terms. So imagine you have this monomer, okay, and we have another monomer just like it, and we want to hook these two monomers together, kind of like hooking together two train cars. Now, this monomer has attached to it an OH group, and this monomer has attached to it a hydrogen. And you guys probably already know that water is HOH. So if we want to hook these two monomers together to build a polymer, all we have to do is rip this off and rip this off and combine it to make a water molecule. That's the dehydration. And then this bond is now open and this bond is open, so what we can do is put a bond between them. All right? And so this bond right here is formed by dehydration. Okay, now the good news is dehydration synthesis is used to bond all the different monomers together to build all sorts of different polymers in biology. So you only need to learn one chemical reaction. So let's look at it now with glucose and glucose. Based on what you just saw, you can probably see that this glucose has an OH group right here and a hydrogen group right here. So all we have to do is take these off, let them become water, H2O, and now we have a bond that can form here and a bond that can form here, so we can hook them together. All right, so here is that new bond we just formed. All right, this is the bond that results from a dehydration synthesis, and this whole molecule now is no longer two glucoses, it's a brand new sugar called maltose. This is the sugar that's in malted milk, frequently used in candies, breakfast drinks like Ovaltine, stuff like that. It's a relatively sweet, easy to make sugar from milk or from plants. All right, so notice how these two hydrogens and one oxygen atom are removed to form the link. All right, so if glucose is C6H12O6, what would be the chemical formula for maltose? All right, so what's the chemical formula for this molecule? Can you figure it out? All right, how would you go about doing this? Well, you know glucose is C6H12O6, and you know maltose, this is glucose, and you know maltose is made from two of these, so maltose should be C12H24O6, right? Because glucose is made of, maltose is made of two glucoses, but we got the problem of the water. We got to subtract H2O. So what this means is it's still C12, but it's H24 minus 2, H22, O minus 1, 5. So the answer would be C12, H22O5. That's a chemical formula for maltose, because maltose actually forms by dehydrating or a dehydration synthesis of two glucoses. Okay, so you got to take a water molecule out for each one of those bonds. All right, we'll stop there. Thanks for listening.